battle, we own the skies. Our Navy owns the sea. And we continue to lead the world, pushing that boundary in extraordinary ways. Technology gave us the night. Now, scientists at the Army Research Lab in Adelphi, Maryland, are working on technology that someday will give us the elements, allowing us to operate in the sand, the dust, the wind, whatever nature throws our way, science will give us control over.
Wow, that's a lot of dust.
When it comes to flying in the desert, the #1 enemy may not be shooting back and literally be as small as a grain of sand.
One of the things that are limiting us the way we operate now is the weather. Sometimes the weather defines whether or not we can execute a mission or not. And so as we develop these technologies, it allows us to operate in high sand conditions, in brownout conditions, in high wind conditions where typically we may not be able to operate an air platform. We're building those technologies as part of our portfolio to allow us to operate in any sort of environment under any weather conditions at any time of day.
It's a big problem, and that's about the only thing that's clear. As we operate in desert conditions, sand not only kills visibility, but it gets in the air intake of the engines. While there are air filtration systems, they don't catch everything. Particles make it through, causing a rapid deterioration of engine hardware. Using a specialized camera capable of shooting 4,000 frames per second, you can see the superheated sand traveling at incredibly high speeds, slamming into the internal parts of the engine, causing the engine to simply wear out and eventually break down.
Those small particles will actually melt, and then they fly in and they basically attack the stator and the rotors. And those are the heart and the guts of this gas turbine engine.
But understanding how the damage happens inside an engine is only half the problem. How do you prevent the damage in the first place? Well, before we can get to that, we must first consider one simple detail. Engines get hot, very hot. So hot, in fact, that the metal alloys that make up the engine parts would melt if not for ceramics. Engineers are able to keep heat under control using ceramic coating. They're already used in engines because of their heat insulating properties and work very well at keeping things cool. Now these scientists are looking at new ways to use ceramics.
So we're trying to make ceramic coatings that still serve that function as insulators and to protect the metal hardware from the high temperatures, while also being more resilient with the added bonus of basically acting like Teflon in a cooking pan, right, where all this incoming sand would just roll right off.
Getting the sand to simply not stick during flight is the holy grail these scientists are working to achieve. But finding the right ceramic material is a tedious and exacting process. In their lab, scientists and engineers recreate the harsh environment inside a flight engine. They expose the coatings to the different types of conditions within an engine and examine how well the coating was able to withstand the test. Observations are noted, changes are made, and they do it all over again. It's time-consuming work, but the results are encouraging.
My part of the program, we're actually coming up with different chemistries and different coating mechanisms that are showing some promise in being more resistant during various heating and cooling cycles. You're using computer models to kind of cycle through those various test iterations faster without having to go back and make a new coating every time.
So the big question is, how does sand affect readiness?
Currently in the field, in some of these desert environments, engines that are designed to operate for 4,000 hours of service are getting pulled for maintenance because of these sand damages at like 400 to 500 hours. 10 times reduction in service life of this hardware. So it's increasing that longevity, sustainability, readiness, and capability that we really think is going to make the biggest impact.
Another barrier to getting this technology ready for the battlefield is the incredibly rigorous conditions these aircraft must endure. Any technology must be able to withstand the harshest of field conditions. There's much work left to be done, but the stakes are high, as is the scientists' dedication to solving the problem.
In the 90s, we were able to, through night vision, own the night. What we want to do with the next generation of systems is own the environment or own the weather. Be able to operate our systems and our platforms with next generation technologies that will allow us to operate in sand, in wind, in rain, in ice and sleet, in high winds, and not be restricted in our movement by those types of operational environments.
Man versus nature, an age-old problem that may be solved with 21st century technology. It starts here, inside the walls of the Army Research Lab, with a group of dedicated men and women, armed with science, trying to save lives.